what a great partner to work with. So I just wanted to mention, it's not all about the software. It's about the people that you work with at OmniSci and how great they are. And
okay, now we have to give a round of applause for Andrew and Venkat.
Great team. Because when you really need help, they're there for you to help you. I think I need to advance my own slides.
Yeah.
So it is all about the data. And those of you who have worked with Nvidia, you know how important the workflow and GPUs are to accelerate that data as it's being ingested. So when I started working with MapD OmniSci, I began working with the taxi data, which is very important geospatial data, vast. And then we went on to pick NASA's repository, their gene repository, the Gene Lab repository that's local here. And we were able to create a blog just pulling data off of their site into the repository, into MapD OmniSci. And we wrote a whole Deep Learning Institute Jupyter notebook and a course around it. So they were very instrumental in working with us on that. But as you know, Nvidia has been very focused on self-driving cars. There's a lot of data there. We're talking about thousands of petabytes of data a month, or daily, going into our different parts, endpoints of our system as we develop this autonomous vehicle data set. So billions of frames, hundreds of petabytes, millions of labeled data each month. We have 1,500 full-time labelers and developers working on training this data and getting this data into the system. When we talk in terms of Go AI and open source platforms and where we've evolved, please go see Josh Patterson's talk, our GM for data science. He can talk about the relationship and what we're doing with OmniSci from an open source perspective. And in working with all of this data, my particular position has been doing all the validation and testing around our DGX systems. And that is our DGX1 and DGX2. So when we think in terms of thousands and thousands of GPUs that we're working with to train this data, we use our Saturn V. And we create these reference architectures so that our customers can take the data that's ingested and know what type of architecture to run that data on. And what they're able to achieve with these white papers is a prescribed workflow and curation of this data so that they can go into their own environment, utilize the infrastructure that we've prescribed, and it's holistic. So you have to look at the network, you have to look at the compute, you need to look at the storage, and you need to look at the entire workflow and that infrastructure around that. So this prescribed methodology helps our customers in this community really understand what to put together to be able to do training and inferencing. I'll be talking more about our DGX pod and how we work very closely with ingesting that information from different platforms, from different GPU accelerated database capabilities like OmniSci. And I'll be talking at 3 o'clock on Wednesday, so please come see me for more information. But here you're looking at our DGX1 pod solution, and what we do is we put together with our partners a configuration that's tailored. In this case, it's tailored to the automotive use cases, and we're able to take our partner solutions, validate those, certify those. We have what we're bringing up called the Raffle Lab, and we'll be having many different applications running in our reference architecture Raffle Lab in our data center that's very close to our Endeavor building here in Santa Clara. So please come see a tour of our data centers and how we're working with all of our ecosystem and all of our partners like OmniSci. When we think in terms of some of the use cases, I mentioned some of those. We started demoing with the taxi data. We moved on to pulling the NASA Gene Lab repository data off and developing use cases around that. We continue to work with NASA as we improve with some of OmniSci's new tools. But moving back here to our automotive example, when you think in terms of ingesting IoT information, for example, and being able to infer that a pedestrian is walking across the road, it's very important to have best practices around the kind of networking, the kind of rack design that you develop, the kind of data sets that you're bringing into this environment, and to be able to test and validate those so that customers know exactly what they're getting in their environment when they're running these GPU accelerated databases. And so this just gives you an idea of one of our platforms, Nvidia Drive platform, and how we ingest that data, we curate that data, label and train that data, and then we integrate that data and we're able to simulate and validate that data for our autonomous vehicles. I mentioned I work very closely with our top tier storage partners. One of our partners is NetApp, and NetApp ONTAP AI with OmniSci. There's a great white paper out there if you want to take a look at how the NetApp A800 has been utilized along with the DGX1 and validated to run the OmniSci database and look at not only the ability to be able to connect to data through the JDBC, but through the ODBC be able to then take that data and make that data flow into other applications as well. What I really love about working with MapD and OmniSci as they became OmniSci was the great user interface. It was so easy for me to come on board to Nvidia to be able to load the entire MapD or OmniSci database and be able to start working with it right away and have a very nice comfort level that I could work with that application without having a lot of background. So very great people-oriented team at OmniSci, and thank you so much for asking me to talk.
Thank you, Becky. Appreciate it.